Okay, I hope we can start our class today. Assalamualaikum warahmatullahi wabarakatuh and good afternoon everybody. We continue our course today and then maybe I need you for 10 minutes or 15 minutes to please pay attention to what I want to explain. Yeah, first of all, actually last 2 weeks we already study about how to derive the sample and what kind of randomness that we can take into account and so on related to the sample, and then the sample we can classify as a random variable. And then this week we move forward. We want to discuss a lot about the sample. Yeah, the sample. Actually, the sample that we want to take is to estimate parameter of population. Yeah, some parameter we already discussed actually, but in this week we will more formalize, yeah, those parameter. Yeah, this parameter, for example, the mean, yeah, here the mean, and the variance, yeah, the variance. And then after we know or we get this sample average or the standard the variance of sample, and then the next problems is how accurate, yeah, accurate this parameter, that the parameter, these parameters compared to the population parameter. So this question also asking how close that the parameter that we get from the observation is closer to the real parameter of the populations. And then we introduce a new how to say, a new term that we can call as a confidential, yeah, confidential interval and confidential coefficient, yeah, confidential coefficient, and the two important parameter, and maybe in other books also discuss about the confidence limit. Confidence limits. Okay. Actually, why we actually, when we have probability distributions, let's say this is a distribution of sample average, and then we have like normal distribution. Why we conclude normal? Because the number of sample is greater than 30, the number of sample each observations, and then the term of confidential interval is like this. Given let's say this is alpha, this is beta, the area between alpha and beta that we can call as confidential interval, and the area before the alpha or beyond the beta here is we can call as confidential coefficients. No, not confident. Not confidential coefficient, but error coefficient. I mean the confidential coefficients is, I mean this beta. This is a confidential coefficient, yeah. Confidential coefficient. Otherwise, the area before the alpha and after the beta, we can call what to say, the standard diffraction. Wait a moment. Okay. The alpha and beta, this is a confidential limit, confidence limit, and for the area of after alpha and before alpha and after beta, this is confidential coefficient. Yeah, this is confidential coefficient. So I hope it's clear. So allow me to rewind again. The area here, this is confidential interval, and the area before alpha and after beta, this is confidential coefficients, and then alpha and beta, this is confidence limits. Yeah, okay. And then what's matter with this parameter? Yeah, actually, yeah, if we want to take a sample, something like that. Again, this is a sample average, and this is the limits alpha and beta. What is the meaning? Once we define the confidential interval, this is the interval that we confidence, or we can say is likely that any observations will be fall in this area. Otherwise, for the confidential coefficient, this area is the area that the average or sample average will likely small chance. Yeah, small chance mean that the chance that the sample average will be located in this area, or in this area has a certain value which is more likely small to happen. Yeah. Okay. And then the next discussion, after we know the confidential interval and confidential coefficient and the confidential limit, what is the purpose of that? The purpose is to measure the accuracy, yeah, accuracy of estimation. What kind of estimation? Yeah, again, the estimation is how to estimate the mean of population, or estimate the variance of the populations. So, and then after that, given the number of populations, we can distinguish into two types. First is single populations. And the second is double population. The single population, we can estimate the mean, estimate the variance, yeah, and then the estimate mean compared to the variance. And for double population, we can estimate the differences of mean, which is the mean 1 minus mean 2, or compare the standard deviation by comparing standard deviation 1 compared to the standard deviation 2, something like that. And in this week, we will discuss start from single populations. So the purpose of single population, we want to estimate the mean of the population, standard deviation or variance of the population, and then mean and variance both. So for example, we have some to say the problem is we want to estimate mean of the populations. And then how to estimate the mean? First, we can conduct the unbiased estimator. What is the unbiased estimator? Unbiased estimator is just simply mean we can compute as average of estimator. which is this is the average from first observation plus average from second observation plus average from third observation, and so on and so on, and divided by n. That's the unbiased estimator. And you can see here from this formula. Okay, for remember, the x1, for example, is result of 1 plus x2 plus x3 until n, yeah, is divided by n. And you can see here, as you have a large number of sample, you will get closer to the population or mean populations, why we can call unbiased estimator. And for unbiased, this is to estimate the mean of population. And how to estimate the variance of populations? It is similar, that is equal to S equal to average of variance. Actually, this is variance from first observation plus variance for second observation plus variance of third observation, and so on, and divided number of observation. And as you know, for example, variance for each observation consists of, this should be xe minus x1, something like that. Ya, per berapa ini? Ya, berarti ini super n, something like that. That's the variance of each of observation, and this is the variance of total observations. And then after that, for example, we want to know result of this one. Result of this one is being like this, because this is estimation, estimation. And also we have another parameter, the variance. We put a hat here. It means that this parameter result from estimations. And then again, if we have let's say, because we conduct multiple times of computation, let's say, then we can extract, we can extract into, let's say, mu1, and we have mu2, something like that, mu2, and then something like this. 3, so it should be 3. So given by different result, let's say this is result 1, and then this is result 2, and then this is result 3. If you have and you realize that, for example, 1 is less than variance 2, and this is the variance 3, yeah, variance 3. So by looking at these conditions, which the best estimation? Given this data, yeah, the answer is number 1. Number 1. Why? Because they has a smallest variance. Smallest variance. The smallest variance means that it's close to the how to say, close to the real number of populations, something like that. Okay. So far, that's all. Any questions before we go to the exercise?
So sir, it's basically like we're doing an observation, and then we get, for example, x1, x2, and x3, and also variance 1, variance 2, and variance 3, and then we use this formula to find the estimated variance and mean, and then we do it again until, like, for example, in this example is three times, and then from those data we compare to each other which one is the smallest, then that one is the best estimator. Is it like that?
Yes, yes. Yeah.
Okay, sir.
Okay. Wait moment. I have like 3 different graph here. Fine. That is fine. Oh, okay. Okay, maybe I can spell this one. Okay, right now you can see here there is for example, this is a result of estimations. Yeah. First, like I call as a sita. Yeah, sita, for example. Yeah, this one, sita 1, sita 2, sita 3. Actually, from the 3 graph here, the smallest variant is the blue one here. This is the smallest variance. What is the characteristic why we can call as smallest variance? Because as a sharpest graph here, it's mean that the variant is smaller, something like that. Okay. Okay.
Sir, can I ask a question, sir?
Yeah, yeah, please.
But why is the smallest become the best estimator? I mean, why is the smallest variant that become the closest variance to the real variance?
Okay. Wait a moment. Okay. actually, the purpose is to estimate the, what to say, that's because, yeah, your question is that because the mu, the estimated mu is considered close to the mean. Okay, why it is close, the closest, yeah, the most close of the mean, since it has the variance smallest, yeah, smallest to the the smallest of the data. Since smallest means that it's really close, yeah, really close to the real mean populations. Something like that. And because it's because the average is close, and then we pick up together, consequently the variant also the best, I mean more accurate to the populations, something like that. Is that clear? No?
So is it like because the X bar 1, X bar 2, and X bar 3 are close together because the variance is small? So that's
Yes.
why we choose the one that has the smallest variance. Is it like
Yes.
that?
Yes. Yes.
Oh, okay, sir. Thank you.
Yeah. You're right that since this x1 bar, x1 bar 2, x1 bar 3 is become likely, it means that we are really confident. I mean, it's I know this is because looks similar between every taken, yeah. So we can believe that this value is closer to the populations, something like that.
Okay, sir. Thank you.
Okay. Okay, let's take an exercise. You can see now, yeah. We have an exercise here. The average zinc concentration recovered from a sample of measurement taken in 36 different locations in a river is found to be 2.66 gram per millimeter, and find the mean, yeah. No. Find the 95% and 99% confidence interval for the mean zinc concentration in the river. Assume that the population standard deviation is 0.3 gram per millimeter. Okay. Please try by yourself, maybe for 15 or until 20 minutes from now.
Sir, I want to ask. I forgot. Is the confidence interval is in the? It's in the like in the middle between alpha and beta, or?
Yes, right. This is a beta. This is alpha, and this is a confidential interval.
Oh, okay, sir.
Okay. From the questions, we can see either the first case is 95%, and the second case it should be another way, yeah. Is 90%.
So is it like we try to find the alpha and the beta? Is it like that
Uh,
based on this
find
question?
find the conventional form means yes, actually find the alpha and the beta.
Okay, sir.
Yeah, finish. No.
Finish.
Finish, yeah. Okay, let's check together. That moment. So, oh, this one? Oh, it's very long. Okay. Okay. So, the first one is find the confidence interval of the mean sinks. Sama mama dong. Sama mama dong. Sorry, there is iklan. Sama mama. Saya lagi ngajar. Sorry. Okay, start with 95%. 95%. So we have draw being like this, and this is the alpha and beta, actually alpha and beta, and then we first identify that the n is 36. Yeah, 36 means that is greater than 30. It means that this sample average will be normal distributions. Yeah, will be normal distributions, and then also given by the standard deviation of population. Yeah, this one, standard deviation of population. So we write thing like this. Let's say for more clear, standard deviation population is 0.3. Okay, and then find A and B. It means that so for 95%, it will be originally what to say, this is for example the mean. Yeah, the mean of populations. So and we found that X bar here to be 20.6. Yeah, 3.6 gram. And then we want to estimate the mean interval, which is beta and alpha. And then beta and alpha, so I write here beta and alpha, new populations. So in this case, for this one is 20.9 minus alpha. This is populations. This is plus 6. Okay. And this one, the alpha, it should be, since it's normal distributions, and 95%, so the alpha, it should be 196. This is the result from 90% standard deviation, mu equal to 0 and the variance equal to 1, and then multiply by the standard deviation of populations divided by 0, no, 6. No, this is no. This is alpha, and this is actually this is not beta, but we can say this is threshold. Yeah, this is threshold. This is tail. Example tail. This is T also. So we can see here, this is 96. This is 0.3 divided by this one, and this will be have 1,96 dikali 0,3 dibagi akar, salah 36. Oh, itu 6 ya, berarti 1,96 dikali 0,3 dibagi 6. This we have 0.038. So we can have the alpha. Alpha will be 22.6 minus 0.98, and for the beta is 2.6 plus 0.081 is equal to 26. Berapa ini? Ditambah 2, dikurangi. 2,6 dikurangi 0,098. 2,502. So we got here something like that. So this is for 95%. 95%. Actually, when we compute for 99, it should be wider. Yeah, is here 90 should be wider. So what is the effect? Actually, the computation change in this value is no longer 1.96, but it will be, wait a moment. The Z is sembilan lima lima kalau 9. Nah. Dari 99. It's around 233. 995. 975. 975 berarti 9. 975. 975. 2,5 berarti itu 995. 995 itu 258. 258. If we use this one 90%, this value will change to the 2.58. 2.58. It means that will be more larger than the alpha here, something like that. Is around, if we compute, so berapa ya? 2,6. Jadi for a new alpha, let's say this is new alpha, this is new beta, second beta 1, yeah. We have alpha 1 become 2.6 minus 2.8 multiplied by 0.3 divided 6. Yeah, it's equal to 258 multiplied by 0.3 divided by 6. 2129 means 0,129. So will be around 2,6 2,6 dikurangi 2,471. Beta satunya berarti 729. Yeah, we found this value. Is there anyone has a same result maybe, or any questions please, or any question please? Which part that still not understand maybe? Hello, everybody. Are you there?
Yes, sir. I think it's
Yes, sir.
So
clear,
far,
sir.
I think it's same.
For me, it's clear, sir.
Yes, sir.
Same? Okay.
Yeah.
Okay. Okay. In this case, we know that this parameter, I mean the variance of populations is given. I mean it's known. It's known. What happens if this is this variance of population is or doesn't known? It's very many situations that we really don't know the variance of the populations. And to conduct this problem means that if we don't know the variance of the population, for example, we have something. Let's say okay, Java, you are permitted.
Okay, thank you, sir.
Yeah. Okay. So right now I can clear this one and then add up with this one. Okay. In this case, the content of 7 similar container of sulfuric acid are, it's given being like this, the data 9.8, 10.2, and so on and so on. And find the 95% confidential interval for the mean contents of all such container, assuming an approximately being normal distribution. So the question is find the mean in terms of confidential interval, and then we don't know the variance of populations. We don't know. Since we don't know, so we remember that last week we got the random variable. The z will be equal to, this is q, this is the s divided the number of samples, square root of number of sample, and you know that this q and the s is random variable. So the z will follow what? Will follow T distribution. Yeah, because we don't know the standard deviation of populations. Okay, for the first step, we search the standard average of the sample average. So it's like a 9.8 plus 10.2 plus 10.4 plus 8.9.8 plus 10 plus 10.2 plus 9.6 divided by what? By 7. And then we can calculate by calculator maybe. 2 plus 10.4 plus 9.8 plus 10 plus 2 plus 9.6 divided by 7 will be equal to 10. And then we find the standard deviation, so it's equal to, for this one is something like this, 9.8 divide minus by 10, and then plus 10.2 minus by 10, and so on, divided by 7, and we got around 0.283. No. It should be square, and for this one is 0.283. Okay. And then right now we already know, and then similar to the previous one, we want to alpha. We want to know the alpha and beta. The alpha actually this one minus this value corresponding to the T distribution with 95, yeah, 95, and this is S per 7 berarti. The data is 7. Also for the beta is like this, plus T95% S per akar 7. And this one is actually 10 minus T95, the distribution T. We can take from the computer or from the internet T distribution table here. The distribution. The distribution is 2, 5. It's around 2, 4, 4, 7 with 6 degree of freedom, yeah. 4, 4, 7. Oh, yeah. This is S is 0.283 divided by 7. And the result, here is around, for this one, the result is 9 is 74, and this one is 10.26. Is correct, yeah? 0.283 divided by square root of 7. Yeah, it's pretty similar. The change is we use T distributions instead of normal distribution. Why? Because the variance is not known. The variance of population is not known. So it's mean that its value here is consists of variance, something like that. Okay. Any question from this exercise? Maybe we can write here the alpha is equal to 9.74 and the beta is 10.26. 95%. Okay. Any questions?
Hello, sir. Excuse me, sir.
Yes, yes, please.
You mentioned that we use the t-distribution if we don't know the variance.
Yes.
So it's just like the example in the question, like we don't have info of the variance, so we use t-distribution.
Yeah, because the variance of the population doesn't know. I mean, there is no information about the variance of population. So in this case, we use T distributions.
Okay, but if we have the information for the variance, like the previous formula, the previous question, we can still just use the normal distribution.
Yes.
Okay.
Sir, I have a question, sir.
Yes, please.
What if the standard deviation or the variance of the population is already known, but the number of sample is not is less than 30, or there's only a few number of samples? So do we use T distribution or normal distribution? Because in the previous meeting you said that if the number of the sample is less than 30, we use T distribution.
Yeah, for the very, what to say, uh, very safe, I mean, how to say, to keep the estimator unbiased, it is better to use T distribution if the number of sample less than 30. Okay. One exception, if maybe in the sample says that this sample or this sample follow normal distribution. So in this case, you should use normal distributions, even we don't know the number of sample. Yeah, usually something like that. Is that clear?
So to be safe, we just use the distribution.
Yes, if less than 30.
Okay, sir. Thank
Yes,
you.
yes. In many situations that we don't know, yeah, and we realize that the number of sample less than 30, it is better, yeah. It is better to use T distributions. Okay, that's all for the one sample populations. And tomorrow we will discuss two sample populations. Is there any more questions related to how to determine the confidential interval? I think, yeah, if we change the problem, we can use similar way to compute the whatever the equation wants. Yeah. Okay, if no question, we finish our class today. And thank you very much for your attention, and see you tomorrow. Thank you.
Thank you, sir.
Thank you, sir.
Yeah.
Thank you, sir.